First of all, I would like to introduce to all of you what is actually the meaning of electrical transportation. Electrical transportation is one of the transport that using of electron and holes in semiconductors under various conditions. Electrical vehicles refers to the use of electricity as power source for various modes of transportation. Electrical transportation is such as trains, car, buses, and bikes. It can be powered by a collector system with electricity from extravehicular sources or powered autonomously by a battery, such as solar panels or convert fuel to electricity using fuel cells or generator. The type of electric vehicles is using plug-in electric, plug-in hybrid, or hybrid electric.
So, for our next slide, I will be sharing about the significance of electric car. The first significance is job displacement and creation. With the existence of electric car, there will also exist opportunities for job creation in the renewable energy and electric vehicle industries. The second significance is transportation fuel innovation. The oil and gas industry could explore new technologies and products to remain relevant in a changing transportation landscape. And the final significance is electric car also give environmental benefits. With electric car, it can reduce air pollution and lower greenhouse gas emissions. This can also subconsciously combat climate change and transition to sustainable energy source.
Okay, I will continue to explain the relationship of electricity and magnetism concept of electric car. As we know, electric vehicles operate using electricity stored in rechargeable batteries that power an electric motor which turns the wheel. The interaction between electricity and magnetic fields plays a crucial role in their functioning. The car's electric motor utilized magnetic fields generated by flowing electric currents to produce rotational motion, propelling the vehicle.
Ever wondered how EVs get from A to B? Is it essentially the same as an internal combustion car, but wired up to a giant battery? Or is there some altogether more subtle trickery afoot? Join us today as we pop the frunk and ask how exactly do electric engines work? Surprisingly, the operating principle behind most modern electric vehicles predates the internal combustion engine by a number of decades. In 1834, a Dutch professor named Sibrander Stratting of Groningen, Netherlands, built his own small electric vehicle. The catch being, its battery was non-rechargeable. Internal combustion engines work on the principle that fuel and air, when compressed and ignited, cause a tiny explosion. That's the combustion part. This explosive force pushes a piston. That piston's linear motion, in concert with a team of fellow pistons, transforms into rotary motion via a mechanical crankshaft. This in turn spins your wheels along the highway. Conversely, the fundamental principle that drives electric cars is magnetism. Everybody knows how opposing poles on a magnet attract and how alike poles repel each other. So let's imagine an experiment using two magnets, one fixed, the other mounted on a nearby rotating shaft. If the two poles nearest to each other on both magnets share the same polarity, say north to north, the magnet on the shaft will be repelled. Because it's attached to a shaft, the shaft will turn. That is until the south pole on the shaft magnet is aligned with the north pole on the fixed magnet, whereupon the shaft will again be still. In our imaginary experiment, we've made the shaft turn a half rotation. All very well, but that won't get us very far on the morning commute. Here's where electromagnetism enters the chat. In a fixed or permanent magnet, like the kind you have on your fridge at home, those magnetic poles are rigid and never change. North is always north, south is always south. On an electromagnet, however, which is essentially a core of metal coiled in electrical wires, this magnetic polarity can be reversed. Imagine one of our experimental magnets is now an electromagnet. If the south pole quickly flips over to north, the fixed magnet will yet again repel the moving magnet, rotating our shaft another half spin. Imagine a very simple circuit involving a battery and a light bulb. Electrons flow in one direction from the battery, through the wires, to the light bulb, and back again to the battery. If we remove our battery from the circuit, flip it 180 degrees, then replace it in the circuit, those electrons will still flow around the circuit, just in the opposite direction. Either way, the bulb lights up. Electromagnets, like light bulbs, work whichever direction the electrons are flowing. But rather brilliantly, the polarity of the magnet gets reversed with the flow of electrons. So to keep our magnets in permanent repel mode, we just need to keep reversing the polarity of the magnet. How do we do that? One way would be to keep popping out the battery and flipping it around.
I will continue with our next slide, which is the exploration of electric car. Exploration of electric cars involve investigating various aspects related to their development, technology, adoption, and impact on the automotive industry and society as a whole. Here's an exploration of electric cars covering different dimensions. The first is historical events. Trace the historical development of electric cars, starting from their prototypes to the first commercially available models. Highlight key milestones and breakthroughs that have shaped the evolution of electric vehicle technology. Moving on to my next point is technological components. Explore the key components of electric cars, including electric motors, battery, power electronics, and regenerative braking system. Investigate how advancements in these technologies have contributed to improvements in performance, range, and efficiency. Next, battery technology. Dive into the specific of battery technologies used in electric car. Examine the evolution of battery chemistries, energy density, charging capabilities, and the ongoing research and development aimed at enhancing battery performance.
Certainly, here an example of the real-world implementation of electric car. The first one is Tesla Model 3. Tesla Model 3 is an electric car produced by Tesla, designed for a mass market adoption. It features a sleek design, advanced technology, and a long-range electric drivetrain. The Model 3 has become one of the best-selling electric cars globally. Contribute significantly to the widespread adoption of electric vehicles. Its success has influenced other automakers to accelerate their electric vehicle development. Tesla 3 is a fully electric car that offers a range of up to 629 kilometers, a top speed of 162 miles per hour, and 0 to 6 miles per hour acceleration of 3.1 seconds. It also features a minimalized interior with a 15-inch touchscreen, a glass roof, and a premium audio system. The second one is charging infrastructure expansions. Government and private companies worldwide are investing in charging infrastructure to support electric cars. This includes the development of public charging stations in urban areas and along highways. The expansion of charging infrastructure addresses range anxiety, making electric car more practical for a long-distance travel and encourage more people to consider electric vehicles as a viable transportation option. This is an important issue for the development of green mobility and the reduction of carbon emissions. The third one is government incentive. Various governments offer incentives to promote the adoption of electric cars. These include tax credits, rebates, and subsidy for electric vehicle purchase. Government incentives help to reduce the upfront cost of electric cars, making them more financially attractive to consumers and accelerating the transition from traditional gasoline-powered vehicles. Next, fleet electrification by companies. Companies such as Uber and Lyft are promoting the use of electric cars in their fleets. They may offer incentives for drivers to switch to electric vehicle or provide electric vehicle options for riders. Fleet electrification incentives contribute to the reduction of emissions from transportation service, aligning with corporate sustainability goals and influencing a broad shift toward electric mobility.
Potential benefits and challenges for electric cars. First, we talk about benefits. Electric vehicles are lower cost than combustion engine cars. It is because right now electric vehicles offer lower cost than combustion engine cars right now. The second one, reduce emission because they have zero exhaust emission and emit far fewer dangerous particles than combustion engine cars. As example, we can say about the release of CO2. Electric vehicles are release far fewer CO2 than combustion engine right now. Second one, challenges. Not many places to charge the electric cars and charging will take hours for full charge. It's because not all station gas have the charging port for the electric cars. The second one and the last one, limit around of range. An average can only go for 160 kilometer for full charge. You, as we all know that the electric cars will have hours for full charge and give us only short ride.
Third, here are several innovations in electric cars. The first one is high-capacity batteries. Advancement in battery technology have led to the development of high-capacity battery, improving the range and efficiency of electric cars. For example, Tesla Model S has long-range feeder, a high-capacity lithium-ion battery pack that can lead for over 1 million miles and reduce the cost per kilowatt-hour by 56%, providing an impressive range on a single charge and is setting a benchmark for electric vehicle performance. The second one is fast charging technology. Introduction of fast charging technologies enable electric cars to recharge quickly, making long-distance travel more practical. For example, the Tesla Supercharge networks allow Tesla vehicles to recharge rapidly, providing approximately 170 miles of range in just 30 minutes, exchanging the convenience of electric ownerships. Wireless charging. Wireless charging system eliminate the need for physical cable connection, providing a convenient and efficient way to recharge electric vehicle. For example, BMW has introduced a wireless charging pack for its electric vehicle, allowing owner to simply park their car over the charging pad, initiate the charging process without plugging any cable. Next, autonomous driving. Integrating artificial intelligence and sensor into electric cars can enable them to drive themselves without human intervention. For example, Wanyo has developed a fleet of self-driving electric cars that can navigate complex urban environments and provide ride-hailing service. The fifth one is integrated vehicle-to-grid V2G system. V2G system allow electric car to not only draw energy from the grid but also to return excess energy back to it, contributing to a grid stability. For example, Nissan Leaf have been involved in V2G pilot project in the UK, demonstrating the potential for electric car to serve as energy storage device and contribute to a grid balancing. Next, Advanced Driver Assistance System, ADAS for EV. Integration of sophisticated ADAS technology tailored for electric vehicle, enhancing safety and driving experience. For example, the Tesla Autopilot system incorporates advanced driving assistance feature, combining adaptive cruise control, lane keeping, and autonomous driving capability, showing the potential for innovation in electric vehicle safety. 7. Solid-state batteries. Solid-state batteries offer higher energy density, longer lifespan, and improved safety compared to traditional lithium-ion batteries. For example, Toyota have been actively researching and investing in a solid-state battery technology, aiming to bring this innovation to market, promoting better performance and safety for electric vehicles. The last one is solar power. Harnessing the energy from the sun can reduce the dependence to a grid electricity and extend the range of electricity car. For example, Lightyear 1 is a solar powered electric car that can travel up to 725 km on a single charge and charge itself with its integrated solar panels.
In summary, we can conclude that electric cars have a lot of benefits, especially for future. However, there's a lot of benefits of electric cars than consequence of the electric cars. This is because electric cars will be the biggest essential in the future, as we discussed earlier.